Welcome. Continue the study of the integration by substitution, also called as UDU. In this video, we're going to see some examples. Now, imagine if you are given something like this. Let's say you have integral of, let us say, cos of x plus 3 dx. Now, we want to find what's cos of x plus 3 dx. Now, we know what is cos of x dx, but what is the difference? The difference is that here we have only x, but here the argument is something different than x. It's x plus something, so it's a polynomial expression. Now, how do we solve this kind of problems? Now, one of the ways to solve this kind of problem is using substitution UDU. Now, you may think that if we are going to use the same procedure we used in the previous video, you would be tempted to think that we have to transform all of this into u and then try to see which du we are going to get. Now, if you take all of this and call it as u, then du is not here because you have to find the derivative of all of this on the same expression. So we cannot take cos of x plus 3 as u because we don't have its derivative here. But we have something else different here. We have something which is this. Now, whenever we have an expression like this, we should always remember that this expression is being multiplied by a constant 1. There is a constant 1 that is multiplying all the expression. If you take only this expression here, the derivative of this is going to give us 1. So we can take this one as u. You take this one as u, it was going to give us x plus 3. Now, the derivative of this is going to give us what? Derivative of this constant 3 is 0. Derivative of x is 1. So we're going to have 1 dx. See, if you take this one as u, we have the derivative, which is this one here. This 1 into this dx here. So it means that we can apply now the substitution UDU to solve this kind of equation. So we put it here to continue. What we're going to have is cos. We are replacing this by u, cos of u. Now our 1 dx is replaced by du. Then we're going to have here du. Now the question is simple. This is an indefinite integral. Now, what is the integration of cos of u du? The integration of cos of u du is sine. It's going to give us sine of u. Because this is indefinite, we're going to have here plus c. But we know that we're dealing with expressions with respect to x. So this is going to be sine of, we replace our u with the value of u we have here. So it's going to be x plus 3 plus c. This is the constant of integration. And then this is done. Now imagine another expression you may have. We converted all of this difficult, complicated thing into something like this, which you are more familiar with. Now imagine if you have, let us say, 2x divided by x squared plus 3 dx. Now, we are only doing substitution UDU because we always see the relationship that one thing is a function or a given expression and the other thing is its derivative. So in this case again, I know I can apply the substitution UDU because if I take this expression here, I know that this is the derivative of this expression here. What I mean is this: if you take this one as u is going to be x squared plus 3. If I make derivative of this du, is going to give us what? See, derivative of a constant 0. This is going to come down, power rule, 2x. Because these are made with respect to x, is going to become here dx. So all this expression here can be replaced by du, and all this expression here can be replaced by u. So as a result, what I will have is integration, which is indefinite integral, of this 2x dx is du of du divided by this all expression here in the denominator is u divided by u, and this is equal to. Now, by the rules of integration, we know that this is going to give us natural log of u, and this is going to be plus c because we are dealing with indefinite integral. But we know that in our case it's not about u. In our case it's actually an expression of x, so we're going to replace u with the actual value of u. So this is going to be x squared plus 3 plus c, and this is the result we find. So we're just trying to be clever. We're trying to identify if we in one of the members of this given expression we have on the other side the derivative of the same, and if we have the derivative, it means you can use substitution u du and we can solve it simply. And another example we can take could be, say you have sine of x squared. This we have an exercise we have done in the first video, so let's not use this one. Let us use sine of 2x dx. Yeah, we have sine of x dx. We know that if it was sine of x dx, we will just put minus cos, but this is not the case here. So we have to try to simplify this, and one of the ways is substitution u du. Now, if we take the substitution here, if we take this sine 2x here as u, we know that we are not getting the derivative of this in the same expression. So we cannot take sine in our u term in our substitution. So let us try to take u as 2x. Therefore, the derivative of u is equal to 2, and this with respect to x is going to become dx. Now, if you see this, okay, we're taking this 2x as this is argument of sine. We're taking this 2x as u, and then du is becoming 2 dx. If you see here, there is no place where it's written dx or 2 dx. It's only dx. Now we have to know how can we replace this to write it in terms of du, and this is the answer. So it means if you have du divided by 2, this is equal to your dx. So this becomes what? This becomes something like this: sine of u, we're replacing our 2x by u, and instead of our dx, what will replace? Du by 2. So we're going to have here du divided by 2. This 2 is a constant, can come out, you have 1 by 2, it's here, and then here you have sine of u du. And how to solve this? Using our conventional way. So it's going to be 1 by 2, and this is multiplying what? Derivative of sine is minus cos, so we're going to have minus cos of u, and all of this is plus c because it's indefinite integral. So we're going to have here minus 1 by 2 cos of u plus c. But we're not dealing with u, we are dealing with a function or expression of x. So minus 1 by 2 into cos of, what is our u? Our u is 2x, cos of 2x plus c. Now, what is the important thing to bear in mind here is that we may be tempted to solve this thing the same way we would solve if we have an expression like this. Like if you have cos of x, you just put sine of x, and then we may think that we just have to take the same argument and put here on the reverse operation, which if it's sine is going to be minus cosine, which is the integration, and then we get the result. But that's not always the case. So that's why we use u du, because if you see, if you see here, this argument here on the cos in the original function was the same on the result. In this case, the argument is 2x, but the function is completely different. Here we just had the same function, but now with direct integral. But in this case, we have this term here, minus 1 by 2. So we should always try to go for substitution u du, because trying to make this will not work.